Have you ever looked at a robot arm and wondered, how much weight can that thing actually lift? Take a small home robot vacuum. Obviously, it can't lift a sofa, but industrial robots at factories? They can easily lift something as heavy as a car engine. Each robot has a limit to how much it can lift. That limit is called the payload. So how do we figure out that payload? In this video, we'll walk through how to estimate the weight your robot actuator can lift, how to size it correctly, and how to build in the right safety margin. And don't worry, the math isn't as bad as it sounds. So what is torque? Torque is a measure of rotational force, the strength required to twist or turn something. In physics terms, torque equals force times distance. Imagine opening a door. If you push near the hinges, it's hard, but push at the handle and it opens easily. The farther from the pivot point, the more torque you generate with the same force. Robot arms work the same way. Let's say you're lifting a 5-kilogram object with a 1 meter long arm. Torque equals 5 times 9.8, 1 times 1, which gives us about 49.05 Newton meters. Now let's talk about gear ratios. Gears help you increase torque. That's their secret power. A gear ratio of 10 to 1 means the motor turns 10 times for every 1 turn of the output shaft. The result? Slower movement, but 10 times more torque. Think of riding a bike in low gear. You pedal more, but it's easier to climb hills. Same with robots. Small motors can lift heavy loads if geared properly. Just remember, more torque means less speed. So the trick is to balance force and speed based on what your robot needs. Let's reverse engineer the motor torque you need. Start by calculating how much output torque your robot arm needs. Then use this formula. Motor torque is equal to output torque divided by the gear ratio multiplied by the efficiency. Efficiency accounts for losses from friction and heat. Let's say your gear system has 80% efficiency. Need 100 Newton meters of output torque with a 10 to 1 gear ratio? Motor torque is equal to 100 divided by 10 times 0.8. That gives us 12.5 Newton meters. But what if you're using a battery-powered robot? High torque motors consume more power. To save energy, you might lower the motor torque and increase the gear ratio. Want to keep motor torque under 3 Newton meters? Let's say you need 100 Newton meters output. Set gear ratio to 49 to 1 and use 80% efficiency. Motor torque is equal to 100 divided by 49 times 0.8. That works out to approximately 2.55 Newton meters. That means even a 3 Newton meters motor can do the job with the right gearing. Don't forget the safety factor. Even if you need 3 Newton meters, it's smarter to choose a motor rated for 6 Newton meters. This buffer protects against shocks, fatigue, and unexpected loads. So what's the goal of robot design? Not overkill, not underpowered, just right. Use only what you need. For home robots, low payload is usually enough. For industrial use, you'll want higher torque and tougher builds. Hope this helped make things clearer. If you found this useful, don't forget to like and subscribe.